As we said, organic compounds are highly modular. So one thing we can do with them is we can react them to form functional groups. So we've already seen some functional groups in the form of alkanes, alkenes, and alkynes. Let's learn about some other kind of non-carbon functional group. So the first up, we have alcohols. And so this is anything where you have a carbon bound to an OH. And then this carbon has some kind of other stuff on it, right? But you have an OH group. So for example, this is ethanol, where we have two carbons combined to an OH. This is the alcohol that you drink to kind of get drunk, right? Then you have methanol, only one carbon. If you drink this, you'll actually go blind. And then you have this one, isopropanol. This is the alcohol you use for like cleaning and stuff. So you don't have to name the individual alcohols. You just have to be able to recognize an alcohol group or draw an alcohol group. Next up, we have carbonyls. Carbonyls are where we have a carbon doubly bound to an oxygen, right? Double bond to an oxygen. And these kind of come in two flavors. The first is the aldehyde. And an aldehyde is a carbonyl at the end of a molecule. So something like this. You got to be careful. Please note that this molecule and this molecule are the same thing, right? We don't have to draw this hydrogen explicitly. Sometimes you'll see it drawn, sometimes you won't. It's totally optional. The most common aldehyde you'll probably know of is formaldehyde, right? Used to preserve things. And it's an aldehyde, right? With two hydrogens on each side. The second type of carbonyl is a ketone. And a ketone is a carbonyl where it's not at the end, right? So there's no hydrogen attached there. So something like this. This is acetone. This is kind of, nail polish remover, other kind of stuff. Remember, these on the end are CH3s. And you can draw all kinds of different ketones, something like this, or, maybe even a diketone. Draw two of them right next to each other. Pretty cool. Yeah, so no carbonyls, aldehydes, and ketones. Third functional group, we have carboxylic acids. Carboxylic acids are called carboxylic acids because they are actually acidic. And so this is kind of like an aldehyde plus an alcohol. So it looks something like this, right? You have some kind of carbon doubly bound to an oxygen and then singly bound to an OH. And so you can draw all kinds of different structures that you want. Right, you can get real creative with this stuff. One carboxylic acid that we've worked with is oxalic acid, and so that looks something like this, right? We've worked with this in lab. So it's two carboxylic acids essentially combined together. Next up, number 4, we have an ether. And so an ether is a compound where an oxygen is bound to two carbons. So these R's are carbons, and then those carbons are bound to something else. So the most popular example is diethyl ether. So there's two kind of ethane groups on either side of this. Remember, we don't have to draw any lone pairs for this oxygen or anything. You can put it in a cyclic structure, something like this. That's known as THF. You don't have to know that, but just be able to identify an ether. Next up, we have an ester. An ester is kind of like a carboxylic acid plus an ether. So it looks something like this, where this R is some kind of carbon, which is then bound to something else, right? And so you can draw a bunch of cool different little structures here that you'd like. Get real creative with it, whatever. You can draw kind of cyclo groups. Pretty cool. And remember, these oxygens do have lone pairs. They're just not explicitly drawn. Next up, we have an amine. An amine is a nitrogen. So some kind of nitrogen. These R's can be carbons or hydrogens. So here's methylamine. If you watch Breaking Bad, that's referenced there. And then we have something like this triethylamine. So this nitrogen with 3 of these ethane groups on them. So this is where kind of fish get their bad smell from. Remember that amines are acidic. They do have this lone pair. You don't have to explicitly draw it. And amines are basic. I said acidic, but I meant basic. And so these can actually react with an acid. So that's why you put citric acid, some lemon over your fish, because this reacts with an acid, acts as a base to form a protonated amine, which is much less volatile. And so it gets rid of the smell of fish. Next up, we've got haloalkanes. And so this is an alkane with a halogen attached. And the halogens here, we're talking about fluorine, chlorine, bromine, or iodide. Right, so there's an example of chlorine, there's an example with bromine, and then there's an example with iodide. Right, you can have all kinds of different stuff. And then finally, we have aromatic compounds. And to kind of really appreciate this, you have to think about your resonance structures. So think back to resonance, CHEM101. So the most popular example, and the only one we'll use in this course, is benzene. So it's this hexagon, looks like cyclohexane, except we have alternating double bonds. And so if you think about all of these carbons, they're all sp2 hybridized. Again, this is called benzene. And so it may look like you have some single bonds and some double bonds. That is not actually true. There's a resonance structure here. So we can move some of these double bonds around this guy right here to form a resonance structure that looks like that. And remember, resonance structures does not mean that at one time it's the structure on the left and other times it's on the structure of the right. It means that the real structure is kind of a weighted average or a superposition of the two structures. So the kind of real structure that it really kind of looks like, and sometimes you'll see benzene depicted like this, is this hexagon and then kind of a circle in the middle because these bonds are rotating about. And so all of these bonds are equal in length and in strength. Cool. And so those are just the functional groups I want you to know. There's 8 of them. Not too bad. Be able to identify them and be able to draw them.